So can
I don't know. I was just wondering, so
we'll see.
with regard to like the choosing the end for your confidence interval,
Yeah.
what's like the overall like? Can you go over like what's the? So I had a solution that was like reasonable, but like, what's like the, like what's the best procedure for it, or like the best practices?
So there's actually, I noticed, I'm still grading project 3. I noticed there are two ways that people were doing the sampling. And I realized that it came down to the wording of the problem. What I meant was, so I wrote compute the survivability to within 99% plus or minus 0.01. And what I actually meant was the probability that it will survive. Do you see this? Do you see the difference?
Yeah.
So I'm gonna accept both answers because obviously that's just a wording thing. But really, like it was a split. Like half of you did, half of you did it one way and half of you did it the other way. So I hope that clarifies it. I won't like if anyone did it completely wrong. I'm not gonna be too harsh on you because that was my fault. I worded it incorrectly.
And so like the other way was like computing like the average survival with like the
Yeah. So the probability that it would survive would be, so let's say, or this is the way I did it at least. So you just do while confidence not met. You compute the final velocity. And then you compute the survivability. And then you say if S, I think it was less than or greater than 0.07. Do I just use this?
and push it down. Push it down.
Then you just, the number of counts, you increment it, which I think most people were doing, or some people were just kind of keeping track of the survivability, so they were keeping track of this S value over however many iterations they wanted to do. But with this, then how do you think you would estimate the probability from just having a number of samples? So let's say n samples, I started out equal to 0. Anytime I come in here, then n samples, I'm just going to do C++ increment. Okay. So I incremented by 1, and what would be the probability? So I mean, yeah, it'd be n over n samples. So n is equal to 0. So then the probability is n over n samples. And I can check if the confidence is met. Most of you got this part using the 2.58 for the 99%, 99% confidence. But then if basically 2.58 times the square root of, it's like p times 1 minus p over n samples. If that's less than 0.01, then we're done. Break. That's the basic idea. Yeah, but if you did it the other way, that's perfectly fine.
Like that, I feel like manually do several times when I observe it, then I choose the end as the.
Yeah, so I mean, and you're observing it
I can
as.
guarantee that the sample number is large enough by observing several results. Is that okay?
Observing several results. So like
I try to compute this sort of thing for different times, and I finally I observed the safety the number of samples might be like more than 7,000, and I fix it to 10,000, which can be guaranteed to be safe. Is that fine?
Like trial and error basically.
Yeah.
Can you repeat how you're actually computing whether your confidence is met though?
Like for the estimation of the standard deviation,
Yeah.
like I run it for several times and I observe the result.
Yeah.
And I capture like the observed rate and take the maximum. So
Take the maximum.
which can make the number of samples that I need maximum.
Okay.
Then I
Okay.
compute the large n that I got. It was around 7 or 8,000.
Yeah.
Then I fix it to 10,000 to be safe.
Okay.
Then I use this number to calculate.
I think that sounds reasonable. That sounds like a reason. I mean, yeah, I guess you kind of invented your own way, but that sounds okay. Yeah, but most people, what they did here is instead of computing this, they computed, or let's say instead of computing all of this, they just kept track of. Basically, I noticed a lot of people had this thing called an S list. Yeah, I guess there was some collaboration. And they just took the mean and standard deviation using MATLAB built-in functions, and that's fine. I'm okay with that because when I saw this, I realized, yeah, you're computing the standard deviation of the survivability, which is technically what I wrote, so that's okay.
So does the p times 1 minus p represent the standard deviation?
Yeah.
Yeah, that's
Can
because
I-
that's the standard deviation of like an indicator variable.
yeah.
Yeah, if you're gonna get similar results if you actually call STD of your if you keep a list of 0 and 1s and you call STD
Right, if you
on
keep
the
it-
list
well,
of
but that's
0
the thing
and
is
1s,
people
you will
were-
get pretty much the same thing.
Yeah, but people were keeping the floating point values of this.
Yeah.
Yeah, that's different from this p minus p times 1 minus p.
Yeah.
So to get the square root of p times 1 minus p, you actually have to keep a list of 0s and 1s, right? Depending on if s is greater or less than 0.7.
Yeah,
And
so
then compute the STD of this list of 0 and 1s. Then you're gonna get the
the,
square root of
the thing is that I think everyone who did that ended up with, you're gonna end up with lower samples because you're being optimistic with that sampling method, right? Because if you keep the 0s and 1s, that standard deviation is gonna, well, I guess, yeah, the standard deviation is gonna be higher than if you kept the actual values, which means that that means that you're gonna break sooner.
So yeah, one example is if all your samples are 0, right? If you use MATLAB to compute STD, you're gonna get 0.
Yeah.
But actually, it should be like